They realised that water molecules are the smallest objects in an aqueous solution, much smaller than salt, bacteria and even viruses. So they designed membranes with microscopic holes that only let pure water molecules pass through. All they had to do was force an aqueous liquid through this membrane, and in theory, all that would come out the other side would be pure water.
But there was just one problem: osmosis. We've already seen that water flows naturally into a concentrated solution, not the other way out of it. But what the scientists at UCLA were proposing was the exact opposite: reverse osmosis. They'd have to physically pump the concentrated solution through the membrane against the force of natural osmosis that wanted to force it the other way.
The good news for those on an aircraft carrier is that there's water all around. Unfortunately, it's not the fresh water vital to maintain the aircraft or refresh the crew.
So this can make drinking water?
This can make drinking water from seawater.
Okay,
yep.
how?
Okay.
Let's have a look.
Well, first of all, it works just by having a strong pump to be able to put a pressure on the membrane to drive it against the osmotic pressure, and roughly you need twice as much pressure as you do in the osmosis to drive it in the opposite direction.
So this osmotic pressure is the pressure that comes about because of the desire of the water molecules in the weaker solution to push through the membrane into the stronger solution. And you've got to push, you've got to reverse that.
That's right.
Another way.
That's the membrane you use.
Oh, wow. That's the actual...
That's the actual membrane.
I can't see the holes.
You won't.
But that's what it is, isn't it? It's basically just full of holes.
It's full of holes.
How small are these holes?
These holes are 0.5 of a nanometer, okay? If you take a hair, that's 72,000 nanometers. Come down to a bacteria, that's about 10,000 nanometers. Come down to a virus, we're coming down to 100. And this is a half. They're very, very small holes.
So it's fiddly to make this membrane, but once you've made it, that is, I'll have to take your word for it.